Example, we are to find the Wronskian of exponential negative x, exponential x, and exponential 2x. So how do we determine the Wronskian of these particular values? So let's begin. We have our Wronskian of exponential minus x, exponential x, and exponential 2x is going to be the determinant matrix formed thus. So the first row is exponential minus x, exponential x. Then we have e to the 2x. The second row is the derivative, okay, of this particular first row. So we have minus exponential minus x. We'll have exponential x here. And we have what? 2 exponential what? 2x. Then the third row is the derivative of what? The second row, or in other words, the second derivative of the first row. So if I differentiate this one again, I'll get exponential minus x. Differentiating this one, I'll get exponential x. And differentiating this, I'll get 4 exponential 2x in this way. Okay, so we've gotten a 3 by 3 matrix, a 3 by 3 determinant matrix for 3 solutions in which we want to investigate their linear dependence. Now, to find the determinants, to evaluate the determinants, as usual, factor out the things that are common in the respective columns. In the first column, exponential minus x is common, so factoring out, you have 1 minus 1, then 1. In the second column, exponential x is common. Factoring out, you get 1, 1, 1. And the third column, exponential 2x is common. Factoring out, you get 1, 2, 4. Is that okay? 1, 2, 4. So solving the Wronskian of exponential minus x, exponential x, exponential 2x. Okay, this is what we have. Exponential x minus x times exponential x is going to cancel out, or in other words, going to give me exponential 0, which is 1. So 1 times exponential 2x is exponential 2x. So let me expand the determinants like this. Starting with this term, I'll have 1. Okay, so taking the minus of 1, which is this particular determinant over here, 1 times 4, or let me just write it fully for you. So I have 1, 2, 1, 4. Then going over to this one, I have minus 1. Then the minus of this guy is minus 1, 1, 2, 4. And finally plus 1. And if we take the minus, we'll have as this one over here. So you're looking at this whole matrix here. That's minus 1, 1, 1, 1. Is that okay? So let's solve. So our Wronskian of e to the negative x, e to the x, e to the 2x is going to be exponential 2x. How did we get exponential 2x? This times this times this gives you exponential 2x. So you have, then when you do 1 times this one, you're going to get 4. Okay, then minus 2 on this place. Okay, 1 times 4, 4, and 1 times 2 is 2. Then minus 1 into, okay, minus 1 times 4 is negative 4, and 2 times 1 is minus 2, of course, minus 2 like this. Then you now have plus 1 times whatever is still whatever, then minus 1 times 1 is minus 1, and 1 times 1 is 1, so you have minus 1. So if we solve, we have exponential 2x into 4 minus 2 is 2. 2 minus 4 minus 2 is minus 6. And we now have plus minus 1 times minus 1 is what? Minus 2, like this. So when we resolve, we're going to get exponential 2x is equal to 2 minus 2 plus 6. And this is 6 exponential 2x. So our Wronskian for e to the minus x, e to the x, and e to the 2x is 6 exponential 2x. This is not equal to 0. So the solutions There is the comments. The solutions: e to the minus x, e to the x, e to the 2x are linearly independent. Okay, the reason is that their Wronskian is not 0. Now, in exam scenarios, they could be particular about you just finding what the value of the Wronskian is, whether it's going to give you 0 or whether it's going to give you something else. So please, it's important you know how to evaluate the Wronskian. Okay, and I believe if you have been watching this series of videos I've been making so far, you should have gotten good understanding of how to solve Wronskian. So I'll leave it here, and we'll see again in another problem. Don't forget to like, subscribe, share, hit the notification button to stay updated on incoming videos. So see you till next time.